Hey everyone, let's talk about integers. Integers are super important. First of all, we have to know what integers are, but the reason that they're important is because we are going to be using integers when we evaluate expressions, when we solve equations, and a lot more in math. So you have to make sure you understand them, specifically how to add them together and of course subtract, multiply, and divide. But let's focus on adding for this video. Integers, if you notice my messy little number line in front, 0 is in the middle of the number line and you have your positive integers to the right. We know that there is a number between positive integers. Well, lots of numbers in between, like 1 and 2. What's between 1 and 2? 1.5, 1 1/4, a lot of different fractions and decimals. Fractions and decimals are not considered to be integers, just whole numbers and their opposites. Now, the opposites are the negative numbers on the left side of the number line, -1, -2. Again, we know that there's numbers in between -1 and -2, but there aren't integers. They're rational numbers. Fractions and decimals are rational numbers. But what you see right here are your integers. So let's talk about some different scenarios about integers. One of the easiest scenarios to talk about is dealing with money. So if I have $5 and I earn $2 more, how much money do I have? $7. Do I have a -7? No, I earned money. I had money, I earned money. A second scenario is when you owe somebody money. So let's say you owe somebody $5 and then you owe somebody $2 more. So together we're owing this and then we're owing that. So together I'm going to add up how much I owe. That means I owe somebody now $7, which means I have -$7 because as soon as I get that money, it's not mine. I've got to give it to the person I owe. Here are two scenarios: positive integers added together, negative integers added together. Now notice what we did is 5 plus 2 is 7. Here, 5 plus 2 is 7. So in our minds, we're adding no matter what. However, in the first scenario, it's positive, so our answer is still positive. In the second scenario, it's two negatives, so our answer is still negative. Now, the third scenario is when we have one positive and one negative. And this is when a lot of times students get a little confused about what to do. So let's say you had $5 to begin with, a +5, and then you owe somebody 2. Okay, so if I have $5 and I owe somebody $2, I'm giving them $2. So what I have left is just $3, +3, because I had more money to begin with than what I owed. So the other scenario would be if I started with only $2 and then somebody said, yeah, I bet you $5 you can't do that, and you couldn't do that, so you lost $5 on the bet. Now you can give them the $2 that you have, but how much more money are you still going to owe them? You still need to somehow get $3 that you don't have yet. So you're considered to be -$3. You still owe $3. So in this case, even though I see an adding sign, did I really add the 5 and the 2 in my head? No, that's because they were not 5 and 2. They were 5 and -2. Or 2 and -5. So in my mind, when I have a positive and a negative, in our minds, we're actually subtracting the absolute value of the two numbers. The absolute value of -2 is 2. So 5 minus 2, 3. The absolute value in the second scenario of a -5 is 5. 5 and 2, subtract and get 3. Now, how do you know if your final answer is a positive, like this first one, or a negative, like that second one? Well, looking back at the problem, it depends which absolute value is bigger. Here, you had $5. You started with a more amount than what you owed, so you still have positive in the end. Here, you owed more, so you still owe, since you owed more than what you originally have. In the second video, I'm going to talk to you about a fancy word named algorithm that has helped my students keep these integer rules straight in their minds.